Today we are going to solve quadratic equations by taking square roots. So if you've been kind of keeping an eye on what we've been doing, this is the third way we have talked about to solve a quadratic equation. So the first was by factoring. The second was by graphing and finding the zeros or using the intersect feature. And now, today we're talking about solving using square roots. So we have some learning goals. We need to be able to simplify radical expressions by hand. The reason we need that, and the reason why you did the Let's Get Radical to review that, is because we have to write our answers in simplest radical form. So then obviously we need to be able to solve quadratics by using square roots. These two actually shouldn't still be on there because that's what we did in yesterday's lesson. So just brief review of what you did on the Let's Get Radical. On A, in order to simplify the square root of 500, you can either do the factor tree method, or I always do biggest perfect square method because I think it's faster. So I know that 500 is divisible by 100. It's 100 times 5. So then if I give them each their own square root and separate it, the square root of 100 is 10. 5 doesn't have any perfect square factors, so that is as simple as it gets. B, 3 radical 12 times radical 6. You have two choices here. You can either simplify first and then multiply, or multiply then simplify. It does not really matter. Since the number's relatively small, I'm going to go ahead and multiply. If it were really big, I would probably simplify first just so that the numbers didn't get so large, but those ones are relatively small anyway, so I'm just going to go ahead and multiply those. Remember, you do numbers times numbers, radicals times radicals. So 3 times the 1 that wasn't written out here on the outside. On the inside, 12 times 6 is 72. So now I just need to look at 72. That breaks down because it does have perfect square factors. The biggest perfect square factor it has is 36. So if I give them each their own symbol here, radical 36 is 6, so I've got 3 times 6, which is 18, and then left under the radical is my radical 2. C is different because this has division, which means I need to rationalize the denominator, but first I need to separate them, give them each their own square root. So square root of 25 is just 5, so I've got 5 over radical 3. I can't leave a radical in the denominator, so I'm going to multiply top and bottom by radical 3. So I've got 5 radical 3 over 3. Last one, give them each their own symbol here. And in this case, neither of those simplify, so the only thing wrong with it is the fact that I've got that radical in the bottom. So multiply top and bottom by radical 11. So that gives me radical 22 on top, a plain 11 on the bottom for my final answer. So hopefully if you were still confused after we talked about the Let's Get Radical, hopefully that helps a little bit more to remember how to simplify your radical expressions. So now, moving on to the second learning goal, I can solve quadratic functions by using square roots. Very simple steps here. You solved by square roots in Algebra 1, so this concept shouldn't be new. But here is the first step that people, for some reason, miss this step. And that is, they get all excited when they see the squared and they know that they're going to take a square root, that they forget that in order to take the square root, you have to get that squared term all by itself first. So I'm putting double stars and underlines next to this. You cannot take the square root on both sides until the squared term is alone. So what's that look like? On example 2a, to get the squared term alone, my squared term is x squared. So I'm moving everything else away from the x squared. So first I would add the 6 here. So 4x squared equals 48. Divide both sides by 4. X squared equals 12. Okay, so I've gotten the squared term by itself. Next step is to take the square root of each side. So square root of the left, square root of the right. On the left side, square root of x squared is x. On the right side, notice I've got a parentheses. Don't forget the plus and minus. Whenever you solve by square roots, the step after you write the square root symbol should have a plus or minus in front. So I've got plus or minus radical 12. Next step is to simplify. Do not use decimals. Decimals are not acceptable. You need to simplify using these rules. So, square root of 12. 12 is divisible by the perfect square 4. And so, square root of 4 is 2. The 3 is stuck on the inside. So, plus or minus 2 radical 3. B, same idea. To get the squared term alone, on this one, I need to just divide by -5. So I've got x squared equals 9/5. Notice it's positive because I had 2 negatives, and 2 negatives make a positive. Next, take the square root of each side. In the next step, remember you need the plus or minus. So you got plus or minus the square root of 9/5. I need to simplify that. So give them each their own symbol, square root of 9 over the square root of 5. Square root of 9 is 3. So I've got plus or minus 3 over radical 5. Now this looks very similar to what I had in C with the numbers switched. So here I just need to multiply top and bottom by radical 5, which is going to give me, again, don't forget your plus and minus, 3 radical 5 on the top, because 3 times radical 5, and on the bottom, radical 5 times radical 5 is just 5. So plus or minus 3 radical 5 over 5. All right, same idea. These next two just look different because the squared term now is a quantity, but this is my squared term. That whole thing is what I want to get by itself. So I'm going to get that by itself by dividing both sides by 3. So x minus 2 squared equals 7. This is the squared term. It is alone. I always get people who try to say, okay, now I add the 2. You can't. Order of operations doesn't let you do that. You've got this exponent here. I have to get rid of that exponent before I can do any adding. So once the squared term is alone, it doesn't matter whether it just looks like x squared or whether it's a quantity. The next step after you get the squared term alone is to take the square root of each side. So square root here, square root here. Square root of x minus 2 squared is just x minus 2. On the right side, I need my plus or minus, and then I've got radical 7. Radical 7 doesn't break down, so I can skip step 3 because it's already simplified. This is the first one where after I look at step 3, I have something else to do because my variable still isn't alone here. X isn't by itself. So now I need to add 2 to both sides. So I've got x equals, the way that we write these, the plain number goes first, so 2 plus or minus radical 7. Again, those are not like terms. When we reviewed what we did on Let's Get Radical, you can't add a plain number and a radical together, so we just leave it like this. 2 plus or minus radical 7. All right, last one, very similar to what we had in C. Again, this right here is my squared term. So that's what I want to get alone, which means I need to get rid of this 1/5. Hopefully we know by now that you get rid of a fraction by multiplying by the reciprocal. So I'm going to multiply both sides by 5. Those will cancel, so I've got x minus 4 squared equals 30. So now I just need to take the square root on both sides, so square root, square root. Again, the square root of x minus 4 squared is just x minus 4 because the squared and the square root are opposite operations. They undo each other. On the right side, again, don't forget your plus or minus, and then I've got radical 30. So I look, and radical 30, you would think that it might break down. If you were doing the factor tree on 30, maybe you do 3 and 10 and then 2 and 5. It does have factors, but it doesn't have any perfect square factors. There aren't any of the factors that double up. So there's nothing I can do to simplify radical 30. That's as simplified as it goes because it's not divisible by any perfect squares other than 1. So no simplifying on the radical to do, but I do need to finally get the variable alone by adding 4 to both sides. Again, these are not like terms. You cannot add a plain number with a radical. We keep them separate, so it's going to be 4 plus or minus radical 30. So hopefully that review has reminded you of what you learned about solving square roots in Algebra 1. That is it for this lesson.